Okay, Oak Rovers, this is a video from section 8.1.2 in Algebra Connections, which is called Factoring with Generic Rectangles. And at the beginning of this section, they talk about the importance in mathematics of finding patterns. And the pattern that we found from 8.1.1 was Casey's pattern. And I just want to make sure that you understand what Casey's pattern is before we go on to today's problem, or 8.1.2. Now, the pattern that they came up here, they have 2x and 15x. There's a relationship between those two numbers and 5 and 6x squared. And the relationship between them is their products are the same. What that means is 6x squared times 5 is 30x squared. And 2x times 15x is also 30x squared. So what's common about those is the cross products, or the diagonals. If you multiply them out, they have the same product. And that's going to be important as we learn to factor quadratics with generic rectangles today. So let's go on to the next section. Number 12. It says examine the generic rectangle shown at right. Review what you learned in problem 8.1.1 by writing the area of the rectangle as a product and sum. So what you're going to have to do in this problem is you're going to have to factor out this row and find the dimensions, the length and the width of this generic rectangle. And then after you do that for part B, you're going to have to see if the generic rectangle fits Casey's pattern for diagonals. And then you're going to have to show that with your work. You're going to have to write that out. So you're going to have to see if the diagonals fit Casey's pattern. So you're going to have to write both of those out for problem number 12. Okay, then we're going to go on to 13. And 13 has a bunch of parts to it. And this is going to be basically stepping you through how to factor quadratics with generic rectangles. It says to develop a method for factoring without algebra tiles, first study how to factor with algebra tiles, then look for connections with generic rectangles. And it says using algebra tiles, factor 2x squared plus 5x plus 3. So what they want you to do is draw that with algebra tiles. Draw the algebra tiles, so 2x squared plus 5x plus 3 makes a rectangle. So you do that just like we did yesterday, or just like we did in the previous section, where you draw your bigger pieces, your x squareds in this case, in the bottom left, and your units up in the upper right, and see if you can draw a rectangle with it. Okay? After you do that for part B, what you're going to have to do is factor with tiles like you did in part A. You need to determine how the tiles need to be arranged to form a rectangle. Using a generic rectangle to factor requires a different process. It says Miguel wants to use a generic rectangle to factor 3x squared plus 10x plus 8. He knows that 3x squared and 8 go into the rectangle locations shown at right. So remember that we use our big tiles down here in the bottom left, they're x squareds, and I have 3x squareds, and in the upper right, I have my small tiles are positive 8. Okay? Finish the rectangle by deciding how to place the 10x terms. Then write the product and write the area as a product. Now remember that this diagonal has to have the same product as this diagonal. But these two squares have to add up to the middle term, which is 10x. So see if you can go ahead and do that. So go ahead and try that. Remember that the product of these two things, by Casey's rule, has to have the same product as these two. So the product of these two has to be, oh well, this is 28 or 24x squared. So the product of these two numbers has to be 24x squared. But they have to add up to that middle term, which is 10x. So see if you can do that. Okay. Kelly wants to find a shortcut to factor 2x squared plus 7x plus 6. She knows that the 2x squared and the 6 go there. She also remembers Casey's pattern for diagonals. Without actually factoring yet, what do you know about the missing two parts of this generic rectangle? Okay? So now you have to think. By Casey's rule, what do you know that these two things have to multiply up to? And then by the sum that they give you right there, what do these two have to add up to? That's what they're trying to ask you in these things. So go ahead and write down the product of these two, and then the sum of those two numbers. For part D, to complete Casey's generic rectangle, you need two x terms to have a sum of 7x and a product of 12x squared. Create and solve a diamond problem that represents this situation. Now remember, the product of a diamond problem goes up here, the sum goes down here. These are the two factors of the product and the two addends of the sum. And then use your results from the diamond problem to complete the generic rectangle for 2x squared plus 7x plus 6. Then write the area as a product and a sum. So you need to be able to do that, see if you can finish off this problem. Okay? Number 14 says this: factoring with a generic rectangle is especially convenient when algebra tiles are not available or when the number of necessary tiles becomes too large to manage. Using a diamond problem can avoid guessing and checking, which can at times be challenging. Use this product from problem 13 to factor 6x squared plus 17x plus 12. The questions below will guide the process. Okay? So here's what it says. It says when given the trinomial such as 6x squared plus 17x plus 12, what two parts of the generic rectangle can you quickly complete? So what they want you to do for A is to draw out a generic rectangle. It's not written there, but draw out a generic rectangle and put two of these numbers where you know they must go. Now I'll give you a little hint. Remember, the big pieces got to go in the bottom left-hand corner, and the small unit tiles have to go in the upper right-hand corner. So you have to figure out how many big pieces you have in the bottom left-hand corner and how many unit tiles you have in the upper right-hand corner to make your generic rectangle. Then it says next, how can you set up a diamond problem to help you factor a trinomial such as 6x squared plus 17x plus 12? Now remember, in your generic rectangle that you should have drawn for part A, you have two of those pieces are already there. What you need to remember now is that the other two squares that you haven't put in yet have to add up to 17x. But their product of those other two squares has to be the same product as the 6x squared and the 12. So those are going to go into your product and sum. Then it says solve the problem for 6x squared plus 17x plus 12 and complete this generic rectangle. And then it says write the area as a product. See if you can do this. Tomorrow we'll talk about this problem if you didn't quite get it all figured out. But we will talk about this if you didn't quite have it all figured out. Then for 15, use a process you developed in problem number 13 to factor the following quadratics if possible. If a quadratic cannot be factored, justify your conclusion. So now what you have to do is you have to do the rest of these generic rectangles. And what they want you to do with these is they want you to make diamond problems and generic rectangles. For each problem, you have to make a generic rectangle and diamond problem and fill in the boxes that you know go where, and then try and solve it. Okay? And again, tomorrow we will go over how to do these problems if you have trouble with these. And that is all we have for section 8.1.2. When you get done with 8.1.2, you can start up on the homework, which is numbers 16 through 21. Now, I have a stamp sheet in my resources on my page. You can print out one of those stamp sheets, but in order to get the homework checked, you also have to be doing the classwork. I'm going to look at the classwork and homework and make sure you're doing a good job on both before I give you credit for that section. Hopefully this video helped, and we'll see you tomorrow in class. If you have any questions, let me know.